My name's Clayton Stairmand from Harrop Engineering. I'm the Research and Development Manager. Been there for a long time, 16 years, 17 years. We were talking before how long we've been using PTC products, and I came up with version 6 of Pro Engineer, which is probably 27 years or something. So I want to talk about a little bit about us, about what we do, what projects we do, and what software we use and have used over the years. So Harrop was founded in 1955. We're a manufacturing company, engineering, design, a bit of everything. We do programs for OE, automotive programs. We also do a lot of our own design, a lot of our own IP. Probably 70% of what we do is our own IP. And then the remaining 30% is essentially contract manufacturing. Bit of a list of what we're good at. This kind of covers everything that's manufacturing, I guess. We've got a foundry, which used to be next door to our building in Preston, it's now in Adelaide. So the project that I want to talk a little bit about is the engine that's outside. It's got that supercharger on it. So it's a Mustang engine, it's a current Mustang, or maybe a 17 Mustang, an older one. So basically we get CAD data from Ford in the US or from wherever we can get it from. We start with an engine model and start to develop superchargers. So there's a couple of fixed parameters that we have to work around. The supercharger itself, or the rotating group, which you can see in the AR experience, comes from Eaton, a US-based company. So it's a package that we've got to deal with. So we basically work from the top down, I guess, and lay out what we want: intercooler cores, rotating group, and then start modeling around it. So some of the challenges in a modern vehicle are engine bay packaging. Everything's getting quite complex. There's a lot of looms, a lot of systems that we've got to work around. Engine packaging itself, so engines are getting more complicated. The direct injection, everything gets in the way. Every time you want to put something somewhere, there's something that's already there, so it's pretty painful. And then some of the other challenges is that manufacturers now are using engines across multiple platforms, so trying to package protect for other platforms. So this particular engine, there's a port injection version. The new engine is direct injected as well as port injected. And it's in a couple of different platforms. So it's in the 2 different Mustangs. A version of it is in the Australian Falcon. It's in F-150. So we try to package protect as much as we can for those systems. So our design goals: OEM fit function. We want the engine bay to look like it's factory, to work like a standard car, just with a little more power. Scalable, so the stock Mustang is about 270 kilowatts at the axles, thereabouts. So base level would be 400 kilowatts, and our test vehicle is 750 kilowatts at the axles. So it's a fairly scalable package, and I guess we just design around the top end, and then everything under that sort of works. So that's the supercharger assembly. There's some cast parts outside which we can have a look at, and that's basically the CAD of an install kit which is used to fit it to the vehicle. So this is a breakdown of what's on the engine outside. So complete assembly, that casting is outside, so that's the lower manifold. And then obviously all the internals. So this is the part which comes from Eaton in America, the rotating group. That's the intercooler core, so water to air intercooler. Various other parts. Essentially everything is manufactured at Harrop in Preston. So we use and have used pretty much the whole suite of PTC products over the years. So we use a lot of tool design, so doing all of the tooling and the manufacturing of the tools for the foundry. So start with our cast part, which is basically an instance of the finished machine part. Model the tooling, so in conjunction with the guys in the foundry to do all the runners, gating systems, we model the tooling, then we cut the tooling. We've got 25 CNC machines, thereabouts. The collection growing every year. Tooling goes over to Adelaide, gets cast, so there are a couple of the castings that you can see in the bottom corner. Castings get painted, come back to us, then we finish machining. So, reality and digital looks sort of similar, I guess. That's left-hand drive CAD, so it's a little bit different, but so finished engine bay, we want to keep it looking fairly factory, I guess. Some people don't like the all black because they like to see that they've spent all the money on the supercharger. But most people like their engine bay, especially modern cars, that look fairly factory. They want it, they want it to look good, but they want it to look fairly standard. So, some of the software that we use, I guess. Harrop's been using Pro Engineer for 22 years, 23 years. So we've seen and used just about everything. Currently we're using Creo 5. I guess the core things that we use are parametric mold design, machining and simulate. I would say probably 95% of what we design is done in Creo. Some of the other stuff we do, we've got a SolidWorks license. we use it as a translator. We use it as a parasolid translator because all of the CAD data that we get from the OEs is usually in parasolid, and it's a really good translator. So it's all usable. It's all it's good at. We use a couple of other packages for doing some of the more advanced machining stuff, but I guess Creo's, when you start using other packages, it really starts to stand out that the whole parametric thing's really useful, especially manufacturing. We're changing models quite often, so I guess after using it for 20 something years, you get pretty used to, I can just go and change the model, the tooling will update, the toolpaths will update, I'll just repost it and recut it, it's not a problem. But then once you start doing other things and involving other software, it highlights how painful it becomes. It used to be that we use Hypermill for doing really complex 5-axis toolpaths, which is obviously not parametric because you're just working on a step model. So it used to be we could change a part, have a look at the toolpaths, re-output them, repost them, send it, cut the part, no problem. But now it's a fair bit more complicated. Usually they say the toolpaths will regenerate because you can import the new servers, but it doesn't work. So. We've got a fairly decent catalogue of Creo parts, I guess. I think last time I looked at the parts list, it was at about 15,000. So most of those have been generated in PTC products, one way or another. So fair history. So this is a video of an AR experience that Alan did for us on the engine outside, which you can have a look at later on. So this was on display at the manufacturing show. So we've got all these engines on display in our showroom, but you can't really see inside them. So Alan came up with this little experience that you can turn it into something transparent, have a look at it, see what service requirements are, see how it all works. So that's what's inside it. So it's something that we'll look at in the future, I guess, whether it be for marketing information or installation information, working with customers on new designs. That's about all I've got, really. If anyone's got any questions on what we do, how we do it.
As the engine's out there, you can see it live on the iPad as well if you want to see what that was. And that's Creo Simulate results, and that's some ANSYS FEA results overlaid. Wish it was that simple.
Yeah, it makes it look really easy.
Cool. Alright.
That's it.